Before you could even test a new idea for an app, you had to deal with the hardware. You'd buy massive, humming metal boxes and fill whole rooms with them, wiring up racks and hoping the cooling systems held up. And you had to make a very expensive guess. If you bought too few servers, your site would crash the exact moment it got popular. If you bought too many, you burned through your cash on machines that sat entirely empty. That problem disappears when you treat computing power the same way you treat electricity. You don't build a private power plant in your backyard just to turn on a light. You flip a switch, and you pay the utility company for the exact amount of power you use. That is cloud computing, the on-demand delivery of IT resources and applications over the internet. Instead of dropping massive piles of cash on upfront capital expenditures, buying servers before you know you need them, you shift to operating expenses. You only pay for what you actively use, scaling your costs perfectly in sync with actual traffic. By removing the heavy lifting of maintaining physical real estate and hardware, you can test a concept and deploy it globally in a matter of minutes without risking financial ruin. To see how this works, look at the AWS ecosystem as a massive, bustling digital city. To survive in this environment, your applications need a secure, dedicated home. You start by carving out a private lot inside the public cloud, your virtual private cloud, or VPC. The perimeter is entirely sealed. No outside traffic can cross. For visitors, you install an internet gateway, an explicit entry ramp from the public highway. This diagram of the shared responsibility model shows why this setup is so crucial. Notice the blue section at the top. AWS protects the physical hardware of the city, but you are strictly responsible for configuring the network and firewall of your specific VPC lot. Correctly configuring these boundaries gives you a logically isolated environment, allowing you to define exactly which data streams get in and which stay out. Inside your fenced lot, you divide the land into specialized neighborhoods called subnets. This keeps your public-facing assets far away from your private secrets. Directly connected to the internet gateway, you build your public subnet. It's your retail storefront, holding user-facing web servers. Deep in the back, you create your private subnet. This is your underground vault. It holds sensitive databases, with 0 roads leading to the outside world. To govern who crosses the streets between these neighborhoods, you set up a network access control list. It operates as a strict, stateless border checkpoint, evaluating every single packet of data trying to enter or leave the subnet. When millions of visitors suddenly flood your public storefront, your private back-end data vault remains completely invisible and safely untouched by the chaotic outside highway. Now let's travel across town, moving away from core networking and diving down into the AI district, where the advanced machine learning services operate. Inside this district, you'll find Amazon Bedrock. You can think of Bedrock as the blueprint factory. It's a fully managed service that lets you rent access to top-tier, pre-trained AI models. You take an existing AI brain off the shelf and safely plug it into your corporate data for immediate insights. For specialized needs, Amazon SageMaker provides a heavy-duty industrial workshop. You use this space to build custom algorithms from scratch. Operating in this workshop requires serious resources. You need to supply massive raw datasets, build your own data pipelines, and employ a dedicated team of data scientists to train and tune the model layer by layer. So if you want to save months of labor and get standard AI running instantly, you head to Bedrock. But if your business demands a highly proprietary, ground-up algorithmic engine, you set up shop in SageMaker. We've mapped out the essential architecture: the sprawling global city, your strictly fenced VPC lot, specialized subnet zones, and the advanced tools in the AI district. This visual breaks down the shared responsibility model one more time. Look at the stark dividing line right in the middle. Your blue customer data layer rests safely on top, while AWS manages the orange compute and global infrastructure layer below. Notice what is missing from your side of that equation. You've constructed a complete enterprise architecture while bypassing the need for physical servers, concrete foundations, or multi-year real estate leases. By removing physical barriers, the cloud lets a single developer build, test, and scale a global application without waiting months for hardware.